2, 3, 4, 5, 6, 7, 8. And then what's the radius? Would be at 4, right? So if you actually graph this, it actually helps you, in my opinion. 1, 2, 3, 4, 1, 2, 3, 4, dot there, dot here at the origin. This would be the circle that would be formed with this. So the question is, what's the equation of the circle? Because that's what you literally are doing. Well, what's the general equation of a circle?
Y equals x minus h squared.
X minus h squared plus y minus k squared equals r squared, right?
Mm-hmm.
So what would the center coordinate be for this? It shifts over on the x-axis, right?
Right.
So it'd be x plus 4? Minus 4, opposite. Minus 4 the quantity squared. It doesn't go up or down, right? Center. So it's just plus y squared. And then what was the radius again?
4.
4, so
16.
r squared is 16. This is your answer.
I did something completely different.
Oh, really?
Mm-hmm.
I like
You're right.
completely. Yeah, I got it right.
Bailey can't see the
Actually,
screen.
his was a lot easier.
Not
I
all
just did
of
my
it.
steps like.
Wait, how's it 16?
I did that.
Okay. How'd you get equal
The
16?
radius is
now.
4.
And I knew R
So it's
squared
4
was X
squared, which is
plus Y
16.
squared.
Gotcha.
And I completed the
Okay.
square. I
Okay.
mean, this way is a lot easier.
18.
I think so.
18.
I haven't charged my iPad case all year. I don't know how it's still alive.
Ooh.
I did the same thing for 18 too.
What'd you do for 18? Just curious.
I didn't do Y equals -3.
Why does it equal
Why
negative
does
3?
it
How
equal
did you get
-3?
that?
Because R sine of theta equals Y.
Very good. So you have an
Very
identity,
simple.
r sine of theta is equal to y. So if you say r sine of theta is equal to -3, then you can literally use substitution. So you would say y is equal to -3. So I had to do another.
Wait, that's
Oh,
your
I
equation.
put it at 0 or -3, like the quarter.
Yeah, that's.
You could do that, you could do that. But you would have to say -3 and 0, yep. Make sure you include,
I thought it had to be a rectangular. I thought it was 0 for x and -3 for y. 0, -3.
I remember that.
Because that's polar.
you're correct. Yeah, you're right, I'm sorry. That's what it would be in rectangular form,
Either way.
or polar form. So yeah, you would have to say,
0 -3.
Yep.
That's what they did when the book did.
yeah,
Could you keep it as Y equals -3?
y is -3 is what I would put because it's the equation. Because 0 and -3 gives us the actual point, not necessarily a line.
The equation. It's asking for.
Yeah, it does ask for the equation.
That's weird.
So literally what Cal did is not necessarily bad. He said, well, that's the coordinate 0 and 3, which is x is 0, y is -3. But the line that would be illustrated with that would be this line right here.
Doesn't it ask for the equation? It just says
Oh,
change
really?
coordinates.
Yeah,
It says write the equation.
Where?
Oh, I'm sorry, I'm looking at the wrong.
Because the side is X.
Yeah, you can leave it as the polar coordinate, that'd be fine. Okay. All right, now 19 and 20, they shouldn't have been too hard. 19 and 20, that's written in rectangular form, and you have to convert it to polar form. So hopefully y'all can do this. Literally, all you do is you plot these on the polar coordinate system. And so this is x, this is y. So x is 3, 1, 2, 3. Y is -3, 1, 2, 3. Put a dot right there. Always draw that dot to the origin because that gives us the radius of the circle, but it also gives us the hypotenuse of the triangle. And you're making a triangle here. So I always draw the triangle to the x-axis. The base of the triangle is 3. The height of the triangle technically is -3, but it's not going to make a difference because it's going to be squared. So I just use all positive numbers, okay? I do know it's going to be negative, and if you want to put it, that's perfectly fine. So there's two things I have to know when it comes to the polar coordinate. I have to know the radius, which is the hypotenuse, also called the resultant, and I have to know theta. Okay, so which one do you want to solve for first?
C.
All right, C
Or
is
R.
R. So I'm going to call that R. So just use the Pythagorean theorem because this is a right triangle. So R squared equals 3 squared plus the quantity -3 squared. That gives us 9 plus 9. So r squared is equal to the square root of 18, which we can go ahead and, the textbook for this is always going to use decimals. You can leave it in the radicand, that's perfectly fine. Just make sure if you leave it in the radicand, you do need to simplify it.
3 squared root of 2.
Yes, so once you simplify that by factoring, you get 3 squared root of 2, which is approximately equal to 4.2.
And that's where decimal in the instruction.
Okay.
Yeah.
So we have that. Now we have to figure out theta. We have to figure out this angle right here. So what I'm going to use is trigonometry because I have the opposite and I have the adjacent.
Yeah, man.
So is tangent. So tangent of theta is equal to 3 over -3. If you want to include that, that's fine. So it's tangent of -1.
It's -3.
Yeah, negative would be on top, but that doesn't really matter, but.
It would still be -1.
It would be opposite, -3 over 3, which is equal to -1. So since you're looking for the angle, you have to hit your inverse or second button on your calculator. So shift tangent or inverse tangent, the tangent of -1. And when you do that, what y'all get?
-45
Okay.
or 350.
Oh, I got that right.
So when you plug that in your calculator, it should display 3.
It did -45.
It is -45.
It'll do the -45 if
But
you use
subtract that from
-3.
really 60.
Yeah, I did
Isn't that the
-3
answer
by
either
3.
way? Like,
It
both
is-
answers are the same.
It is the answer either way, but the proper answer is to always go from 0 degrees all the way around to theta.
We
That's
did
the
this
proper
in
way to
class
do it.
and we put both as the
I know,
answer.
I know, but the proper answer is always to go around the positive direction.
So do you
for
want
now.
us to just put that
I'd
answer?
rather have the positive direction. So when you punch all this in a calculator, you didn't get 315. What'd you get, 45?
-45. Plus 360.
You get -45, so if you say that plus 360, that'll give you the distance all the way around to the resultant, which you guys already told me was 315. So your answer is 4.2 and 315 degrees.
This one was easy.
Okay,
Yeah.
you guys okay with that?
21 is really awesome. You just plot the point, bro.
And I'll do 21.
Plot points of the appropriate system? Yeah, that's actually quite.
Number 20.
Are you, y'all want me to do number 20?
No.
Y'all tell me.
I
20 is the
really
same
know,
thing.
and you can go
No.
over some more of the
Let
stuff
me
that
give
we
the,
don't
we
know.
already have the answer, because I gave the screenshots of the answers.
I forgot.
25 and 344 degrees is your answer. You get the 25 by using the Pythagorean theorem, and then you take the inverse tangent, and then that's what gives you, it'll give you the angle that you need to subtract from 360.
How do you get 340?
That's right, that's nice.
Negative 16.
I'm gonna do it today.
Okay, you try to reduce it. You reduce it. Yeah. And then that equals negative 16.
What?
You, on that one, you're gonna say tangent of theta is equal to -7 over 24. So you have to hit the inverse button, the shift button, and when you do, probably your calculator will display 16.
Negative.
So the angle will be -16, so add 360 to that, so you get 344.
There's another one.
Oh, I did
And your
24
lips.
-7. Ah.
You write down the ellipse.
Okay? You guys okay with that?
0 is less than E, which
Yeah.
is less than
Corner bora.
Okay. Alright, the top of page 337, write each point in 2 of the polar coordinate forms.
We do 29.
Can we do a polar form?
Does anybody have a question on 20, 23, 24?
Is that the same we just did,
Which is
thing we just
less
did?
than-
Yes, it is the same thing you just did, except you have to write it differently. So that would be an example of where you could put 4.22 and -45.
Wait. Okay.
That if number 21 was under the section for 23 and 24, it's literally just asking you what's the way you can write it other than this way here. There's actually 4 ways you can write every single one of these. Because you actually could go this direction, the negative direction, and call that -4.2. Because when you're given a negative resultant, it implies that you're going toward the origin, which would actually end up being this line over here.
So, like, the first number is gonna be the same, and the second number, you're just changing it to a degree or a radian. No.
No, it's saying that if I got 4.2 and 315 degrees, another way I could write that same resulting line would be 4.2 and negative 45 degrees. Or, and we didn't really talk about this because the textbook never did, so I'm kind of surprised they threw this at you. You can go the opposite direction of your hypotenuse. This is the hypotenuse, this is what I'm working with, okay? So I actually can go the opposite direction.